My name is Gary Kader. I'm the director of the Burrell Memorial Observatory here on campus. And this is a short video to tell you a little bit about the eclipse. Here's what I'm going to cover. I'll talk to you about what eclipses are. We'll give you a little bit of eclipse history, how to safely observe them, and the specifics of April 8th, 2024. All the bodies in the solar system are out in the sun all day long because there is no shade out in space. And so they cast a shadow. The shadow actually has two parts. If you draw a tangent line from the sun through this object on both sides, it will give you the dark part of the shadow. If you do a crossing tangent, which is this line along here and here, it'll give you this outer part, lighter part of the shadow. Now, I don't know if you've ever noticed, but when you're out on a sunny day and you look at your shadow, it's got some fuzz around the edges. And I'll show you that a little bit better later on. Definition of an eclipse, it's when one body passes through the shadow of another. Moon's orbit's not circular, it's actually elliptical, which means sometimes it's closer to us, sometimes it's further away. When the moon is closest to us, it appears larger in the sky. And when it's furthest from us, it appears smaller in the sky. It's also tilted. And that's going to come up. I'll show you what effect that has. But first of all, here's the differences in size. Now, when we're anywhere near about halfway between these two, the moon's not big enough to cover the sun. So you get an annular eclipse. I'll show you what those look like. Fortunately, we're going to be very close to a supermoon. Not quite. We're going to be pretty close. So most of the time, because the orbit is tilted, the shadows pass above and below each other. In other words, the moon will pass below the Earth's shadow and the moon's shadow will pass above the Earth. Over here, the moon's shadow is passing below the Earth and the moon is passing above the Earth's shadow. But if things line up just right and the moon is in the correct orbital position, then the moon can cast a shadow on the Earth, or the moon can pass through the shadow of the Earth. Now, when the moon passes through the shadow of the Earth, that is a lunar eclipse. I'm not going to talk about those. So here's a solar eclipse, and it's only visible, totality is only visible along this very narrow strip. And if you're along that narrow strip, you get to see a total solar eclipse. That's what's going to happen to us here on April 8th. If you're outside that line and in the penumbral part, you're going to see a partial eclipse. If you remember back to 2017, we saw a partial eclipse in here in Cleveland. We were in the penumbral part. The times when the moon is far enough away to where it doesn't cover the sun completely, you get an annular eclipse. They're okay, but not worth going out of your way for. These are worth going out of your way for. So here's what the shadow looks like from space. I told you, it's fuzzy around the edges. You may never have noticed that, but your brain has. And when that changes, that affects you. And we'll talk about that much later in this presentation. Eclipses follow actually a predictable pattern. And it's really impressive to realize that ancient people actually were able to figure out these patterns as to what's going on. They knew they were periodic. And they understood what was going on as far as shadows and what have you are concerned. And so here are the eclipses from 2021 to 2040. Here's the one that we're concerned about right here. By the way, the red ones are the annular eclipses. The blue ones are the total eclipses. Right now, they're about 50-50, but in the future, the moon is slowly moving away from us due to tidal forces. I won't go into that, but there will be fewer and fewer total eclipses in the far future. These are the ones 2041 to 2060. Here's the one in 2045, which is the next one in the United States. Here's an annular eclipse that's going to pass near us in 2048. And then this is the next one in Ohio, 2099. So eat your Wheaties, take care of yourself, you might make it. Okay, a little history on eclipses. Humans have always been fascinated by these things. When they happen, obviously, they affect the two most principal celestial objects in their sky, the sun and the moon. And they knew this was the moon covering the sun for the most part. Obviously, there were some legends about dragons eating the moon and what have you. they're very valuable resource for historians because they can date very specific historical events. They can also calibrate ancient calendars to our calendar, so we know exactly when these things happen. Now, predicting eclipses, particularly solar eclipses, is a bit tricky. But predicting lunar eclipses, people were pretty good at it for a long time. They knew what the pattern was. It's suggested that at Stonehenge in the UK, as early as 3000 BC, some of the stone markings were used to keep track of the proximity of the sun and the moon to predict eclipses. In China, observing solar eclipses was a major element. In fact, they have a great historical record on observing eclipses. They felt that this was a major element in forecasting the future health and successes of the emperor. So if solar eclipses occurred on a date that was not predicted, the astronomers / astrologers, they were discharged, or maybe dealt with a little more harshly. In fact, the Emperor Zongkang supposedly beheaded 2 astronomers, Hsi and Ho, who failed to predict an eclipse in 2023 BC. Talk about a tough boss. The ancient astronomers, as I said, they kept real good records of these things. They recorded 920 different solar eclipses from 2136 BCE to 1785, the current era. This is lifted right out of the text of Razel the Elder. He was a scribe to the Babylonian king, and he describes the sun rising being partially eclipsed. That allowed us to set that date of May 27th, 669 BC. That correlated the Babylonian calendar to our current calendar. And you'll see that's happened a lot of times. Ancient Greek astronomers also had a great knowledge of eclipses, and stories have it that Thales predicted a solar eclipse of the 28th of May, 585 BCE. It put an end to the conflict between the Lydians and the Medes. When the eclipse came through, they thought, uh-oh, something's going on here. The gods aren't liking this. We better stop and agree on some terms of peace. A number of events in the Bible can be correlated with solar eclipses. The Assyrian astronomers recorded an eclipse over Nineveh, which the biblical scholar Donald Wiseman has speculated took place just around the time that Jonah arrived there, and he was urging the people to repent lest the city be destroyed. Eclipse came through, they repented, the city was spared. That happened on June 15th, 763 BCE. So while the Chinese, the Babylonians, and the Greeks were all doing this stuff, dominated the West, Mayans, the Aztecs, the Incas were doing a pretty good job of this in the West. Several eclipses are noted on some of the Mayan monuments. The Dresden Codex records several tablets thought to be lunar eclipse tables. Unfortunately, I hate to say it, the Spanish conquistadors and the missionaries intentionally destroyed nearly all the native written records. So little survives to tell us how good the Mayas and the Incas and the Aztecs actually were. Now, what we did have, though, tells us they were really pretty good at this stuff, so they probably were really good at predicting eclipses. Islamic astronomy became the world's powerhouse in of scientific research during the 9th and the 10th centuries. And Arabic astronomy played one important historical role. There was an annular eclipse on the 27th of January, 632, that was visible in Medina. And that was during the lifetime of Muhammad. It occurred the day following the death of his son, Ibrahim. And so we know that date exactly when that happened. And of course, that happened on January 26, 632, in the modern era. So here's what the whole sequence looks like, okay? Starting up here, you've got just the sun taking a little bit of bite, and then it takes a bigger, or the moon taking a little bit of a bite, and then a bigger bite, and then a bigger bite, and then you hit totality, and everything happens in reverse. This is what totality looks like. This is what everybody's after. The difference between 99% and 100% literally is day and night. And this is another image of a different eclipse. They're all different because you can see the corona. This is the outer atmosphere of the sun. It's extremely hot, it's very tenuous, and hence it's very dim. And it's shaped by the magnetic field of the sun. Astronomers are very much interested in mapping this thing out when it happens, because it's the only time we can really see the corona well is during a solar eclipse. So this gives us some insight into what's going on with the sun's magnetic field. Here's kind of the final sequence. Okay, and we'll come back to this part right here in a moment. What happens during this final sequence is the shadows get really crisp. As the moon covers the sun, the visible part of the sun gets smaller and smaller. And so the fuzzy part of your shadow gets smaller and smaller. So as a result, the shadows get a lot crisper. You know, your reptilian brain is going to kick in and says, something ain't right here. And you may get that queasy feeling, or just, you know, you're kind of on alert. You know, the hair on the back of your neck stands up. You might get a flight or fight response. Really don't know, but that's because the shadows are getting crisper. Even the animals respond to this sort of thing. You'll notice that they're all a little more skittish if you happen to be out on the quad watching the squirrels run around. So this last little bit's called the diamond ring effect for obvious reasons. And then just before totality, you get what's called Bailey's beads. This is the sun shining through the mountains and the valleys on the moon. Okay, some safe ways to observe it. You can project the image using a pair of binoculars, or project it using a telescope, or you can make yourself a simple pinhole camera. And I'll give you a website as to how to make a viewer out of a cereal box. You can put a filter on a telescope. Now, here is the rule, very important rule. If someone has a telescope with a filter and claims it's safe, have them look first. Okay? So I don't care how dark your sunglasses are, they're not good enough. Okay, the only safe way to really observe this thing is with an eclipse viewer or a pair of eclipse glasses. Don't point your camera, a pair of binoculars, a telescope, anything at the sun. You can put filters over the top of these guys and make it work. But this is definitely not safe. Looking directly at the sun is what's unsafe. It's not the eclipse that's unsafe. All right, it has nothing to do with the eclipse. It has everything to do with looking at the sun. If there wasn't an eclipse going on, you probably would have any reason to look at the sun. So during the partial phases, you're looking at the sun. During totality isn't any brighter than the full moon. Actually, it's probably a little less than that. And so it's totally safe to look at. So as soon as the diamond ring goes away, take the glasses off. Otherwise, you're not seeing a thing. One of the things I want to caution you on is don't put on a pair of solar glasses and then try to look at the sun with a pair of binoculars or any other kind of optical aid. That is absolutely no. Okay, here's a math alert to prove it. I know I didn't say there was going to be math, but I'm an instructor in the science department, so got to throw some math in here. Diameter of your pupil of your eye on a sunny day is about 4 millimeters. The diameter of a pair of binoculars is about 50 millimeters. The light gathering power is a function of the area. And if you remember your geometry, the area is proportional to the diameter squared. So if we take 50 divided by 4, that gives you 12.5. If we square that, it gives us 156.25. What's that telling us? That means that the binocular lens is gathering 156 times more light than the human eye. What that means is those solar glasses are not going to work for that. By the way, that's why you can burn stuff with a magnifying glass, okay? I'm sure you've all tried that at one time or another. So if you're going to use a pair of binoculars, make sure you put filters on the lenses, not on the backside. And so some other ways to observe it. Obviously, you have the glasses. This is a shoebox viewer. It's made the same way as a cereal box viewer. This is a NASA website that'll show you how to make a cereal box viewer. Later on, I'll give you a website. It's actually done by Post. Of course, they want you to buy their cereal. It shows you how to do that. You can use a colander. This isn't really a colander. The NASA people said it was a colander, but it's not. It's a steamer that goes into the bottom of a pan, but it still works. Anything with holes in it, okay? Even your fingers crossed, okay? Those gaps create these crescent suns. You can also use the leaves on the trees, but on April 8th, there's not going to be too many leaves running around. The other thing I want to point out is sunspots. Okay, these are these dark spots that appear on the sun due to magnetic anomalies. Won't go into the details, but they are cooler spots on the sun. If you can call 1500 degrees cool, but the sun is 5800, and so by contrast, they look dark. On occasion, they can be large enough to see with the unaided eye. Now, sunspots vary on an 11-year cycle from minimum to maximum to back to minimum again. We are approaching a maximum. So chances are pretty good that we might have some large sunspot or sunspot groups that may be visible to the unaided eye. And so there may be some large sunspots visible. This is what the sun looked like the other day. This sunspot group, just barely visible to the unaided eye. I went out and took a look with a pair of glasses and when it was more over here. And I knew it was there, but it wasn't obvious. Okay, so here's what's going on April 28th. This is the day Cleveland goes dark. This is the path of the eclipse up through Mexico, diagonally across the United States, and then along the St. Lawrence River. Here it is coming through our neck of the woods, through Illinois, Indiana, and Ohio. And then it follows right along Lake Erie, through Buffalo, Rochester. So anywhere along here is good. So some basic data. I said April 8th. That should be burned in your memory by now. Travel across Ohio from the southwest to the northeast. It's going to enter Union City, Ohio about 3:08, leave around 3:17. So it takes just under 10 minutes to go across. Here is the data for Baldwin Wallace University. First contact, I gave it to you in a 24-hour clock. I did convert it from universal time. I'll explain universal time in a minute. So it's going to be 1:59 or about 2 p.m. is when it's going to start. Around 3:13 is when we're going to have totality. It's going to be over around 3:17. And then the whole thing will be over by around 4:30. Now, a lot of people are talking about what's the best place to see this, and everybody wants to be right along this blue line here. And of course, I can't argue technically this is the absolute best place. And so Avon Lake, which is sitting right here on this thing, is going to have about 3 minutes and 52 seconds of totality. We're going to have 3 minutes and 46 seconds here. So, yeah, about a difference of 6 seconds. So it's not that big of a deal. All right, universal time. I said I already converted these. If you'll notice, these times are universal time. Universal time is the time in Greenwich, England. And the reason we use universal time is that way we don't have to convert for all the time zones everywhere. We give you one basic time standard, then everybody can convert it for themselves. So to convert universal time to daylight savings time, you need to subtract off 4 hours. Shadow, by the way, is traveling a little under 2,200 miles an hour. It's zipping along, and you can see that thing coming, and it just goes right past you. Here's the weather prospects. Okay, so they're not great. The oranger they are, the worse they are, okay? If you want to get good weather prospects, you're going to have to go to Mexico. Mexico's going to get jammed. The border crossing Mexico, I wouldn't doubt whether people are in line right now. Here's for the country. Higher you are on this graph, the more cloud cover you're going to have. So here, we're just around 60%. So we have about a 40% chance of seeing this thing, which is not bad, okay? I mean, if you want to get down into Mexico, you got a much better chance. But Cleveland, surprisingly, due to the proximity of Lake Erie, makes it a favorable place. So some things to notice. During totality, you're going to feel the temperature drop. It's basically going to feel like sunset. Automatic street lights are going to come on, that sort of thing. If they're, got roosters in the neighborhood, they're going to crow at the end of the eclipse. They're going to think it's sunrise. You're going to be able to see some stars in the middle of the day, and I'm going to show you what that's going to look like. Some animals, pets, they're going to go through their nighttime bedding routines because they think the day is over. Of course, when the eclipse is over, they're going to wake up and go, wow, it was a short night. And so here's what the sky is going to look like during totality. Here's totality. You're going to easily be able to see Jupiter up here to the upper left. You're very easily going to be seeing Venus. Both of those are extremely bright. You should be able to see them quite easily. Mercury is going to be a little bit of a challenge. Unless you have a very, very clear southwest horizon, Saturn and Mars are going to be difficult. Should be able to see these guys. And just for fun, I'm going to point out this guy here, okay? That guy right there. That little star cluster is known as the Pleiades. And it looks like this in a pair of binoculars. And I can guarantee that every person watching this video has seen this. The reason I can guarantee that is because in Japan, that star cluster is known as Subaru. And that's where they got their insignia. It's a little stylized, but it's kind of cool. Okay, now you got your piece of trivia. Some impacts. Ohio's within 1-day drive of 70% of the U.S. population. Populations along the centerline communities can expect to triple or quadruple. Other places like Berea, they could be very easily double. And as you can appreciate, that's going to put a lot of demand, not on just hotels, campsites, restaurants. Don't plan on going out to dinner that weekend, okay? There's going to be extreme traffic. It's going to stress the local infrastructure. Response vehicles might have some tough time getting through. If you're traveling someplace, expect delays. The adage is arrive really early and stay real late. I'll show you a graph here in a minute. Have a preparedness kit in your car. Be prepared to be stuck someplace for maybe literally hours, okay? Make sure you got your vehicle gassed up by no later than that Friday. I scratched this off because the schools in the area finally, all of them, a number of them were smart enough to do this early on. All of them now are going to be closed that afternoon. Emergency rooms could get crowded. I mean, you dump another 3 million people into Northeast Ohio, there's going to be some stress on emergency rooms, things like that. Local internet. Okay, you got a lot more internet users. You might have trouble getting to the ATM, that sort of thing. Not guaranteeing that, but expect that this sort of thing might happen. So if you're going to need cash for the weekend, get it all early. And, oh my gosh, cell phone service might get interrupted. So the state of Ohio, to their credit, has been working on this thing for 4 years. These are all the agencies that have had some input into it. I hope they've done a good job. Hopefully they're working with the local communities, because the local communities, not the state of Ohio, are the ones that are going to have to make all this work. I don't know this for sure, but I've been told that Avon Lake is actually closing down a grid of streets for emergency traffic only, so their emergency vehicles can get through. Here's what's going to happen. This is eclipse traffic data from the 2017 eclipse. This is time after totality. Here is normal rush hour, okay, 4 o'clock, 5 o'clock in the afternoon. You can see that we are 4 to 5 times normal rush hour traffic. If you've ever been stuck in rush hour traffic, you know what I'm talking about. So don't plan on going anywhere far. If you are going to go someplace, go like 1 or 2 o'clock in the morning, because the next day is not going to be a whole lot better, and it slowly gets better as the time goes on. So if you're going to go stay with some friends, make sure they're really good friends, because you're going to be there for a while. So some final thoughts. This is a human experience. Okay, this is a really neat connection to the cosmos. Enjoy the moment. This may be your only time you're going to get to see one of these things. Try to share it with other people. We are social animals, and we like sharing neat things with each other. That's why even when it's 15 degrees below zero, there's 70,000 people down at Cleveland Browns Stadium. Don't try to take pictures. There'll be lots of pictures available. If you're fiddling with your camera trying to do this, you're going to miss the whole thing. Just enjoy the moment. Get real Zen, all become Buddhists, okay? And live in the moment. Again, you need to use the special glasses during the partial phases. It's not the eclipse that's dangerous. It's staring at the sun. Totality is totally safe to observe without the filters. After totality, as you saw, it's going to be gridlock. Just, resign yourself to it. Okay, the next one in Ohio is going to be in 2099. So eat your Wheaties, exercise, whatever. You might make it. Next one's going to be 2045. You'll probably make it. I'm going to try. Have fun. Really enjoy this. Okay, here are some websites that you might want to check out. Destination Cleveland's got a list of a lot of things that are happening. There's lots of watch parties going on all over the place. State of Ohio, they're primarily concerned with safety. Yeah, they have some basic data, but they're really concerned about safety and local governments. This is an interactive map. You can click on anything on there, and it will tell you exactly how long the eclipse is going to be, when it's going to kick in, when it's going to be over. Here's another NASA site that tells you a lot of safe ways to observe the eclipse. Eclipse 2024 has got a lot of data. Here's a STEM activity site, and here's that cereal box viewer. If you've got, young kids or whatever, this is a fun little project for them, and this is a video that was produced by Post. And of course, they want you to buy Raisin Bran. Okay, a word from your sponsor. This is my place. If you haven't seen it or haven't been there, shame on you or shame on me for not promoting it enough. This is the Burrell Memorial Observatory. It's as far north on campus as you can get and still be on campus. We are not having an event at the observatory. This is not a telescopic event. This is a naked eye event. And we're expecting a lot of people to show up. So we are having an event at Finney Stadium. The doors open at 2 p.m. Totality is at 3:13. First 5,000 people get glasses. There will be entertainment. And you'll get a chance to listen to me drone on a little bit about what's going on with the eclipse. So we'll explain what's happening again. So I hope you can make it. Let's really hope for clear weather. And we'll see you all at Finney Stadium on the 8th.